Hello everyone, my name is Sujit Anand. I'm from the Global Open Data for Agriculture and Nutrition, GODAN. On behalf of the Global Open Data for Agriculture and Nutrition, it's my great pleasure to welcome you all to our webinar series. And today we have an excellent webinar on the space for agriculture in developing countries. And I'm very happy to welcome the speakers, two excellent speakers who will be sharing their experiences and work they have been doing in this area with all of us. It's David Taverner from the Caribou Space. He'll be speaking on behalf of the UK Space Agency as well as, and Jacqueline Parker from Environment Systems. So they will be talking, sharing their experiences on this UK Space Agency's International Partnership Program. So one of the reports they published as well, which is very interesting report, which highlights that space sector is well placed to contribute to new types of information and tools to form part of the solutions to the major challenges facing the agriculture sector in the developing countries. And I would like to introduce our two speakers. First, I would like to introduce David Taverner. He's a senior director at Caribou Space and was a co-founder of the DFS Lab, an early stage incubator that supports high potential entrepreneurs launch fintech business in developing countries. His career has focused on using space, mobile, internet, and renewable energy technology to address challenges in developing countries. David supports the UK Space Agency's International Partnership Program, which is a £150 million fund to use space technology to benefit developing countries. He also supports ESA's Earth Observation for Sustainable Development Program, defining its future strategy and plan. Previously, David led research for USAID and the Digital Impact Alliance on their paper, Closing the Access Gap Innovation to Accelerate Universal Internet Adoption, and managed an online community to build links between the space industry and developing countries for the satellite applications Catapult. David was Senior Director at GSMA Mobile for Development, supporting the department's growth from a 4 to 75% world-leading team with over £50 million funding. David co-founded and led the different initiatives like the Connected Society, the GSMA's Intelligence, Mobile for Development Intelligence, Mobile for Development Utilities, and Green Power for Mobile. Our second speaker, Jacqueline Parker, is a principal consultant at Environment Systems with over 25 years experience in environmental and agricultural monitoring and project management. She has led strategic reviews of the UK's long-term environmental monitoring schemes and produced scoping studies and business cases to support investment in monitoring. With a particular interest in the development and practical application of innovative techniques, she helped develop the Environment Systems Spatial Analysis tool for natural capital evaluation. Jacqueline is currently the project manager of EO for Cultivar, a 4-year international collaboration project between the UK, Peru, and Colombia, funded through the International Partnership Program run by the UK Space Agency. EO for Cultivar is developing satellite-derived crop monitoring and forecasting analytics and case studies on natural resource management to help agribusiness and advisory services in Peru and Colombia tackle complex agriculture production challenges. Jacqueline has an MSc in Land Resource Management from Cranfield University and a BSc Honours in Geography from Aberdeen University. So we have two great speakers who will add a very important and interesting topics, especially for the GODAN capacity development community. So I'm very pleased to welcome both of these colleagues to share their experiences. And I want to thank all your participants for joining today. And you will all have opportunity to ask questions at the end of the presentation. Please use your chat window. You can see the chat window in your screen. So you can type your questions in the chat window. And once the presentation is finished, we will try to answer the questions. So now I want to hand over to David.
Hi everyone, David Taverner here. Hopefully the audio is okay. Let me know through the chat box or the questions box if it's not. So David Taverner from Caribou Space here. Thanks for the introduction. Caribou Space is an organisation from the UK focused on supporting a variety of organisations such as space agencies, governments, development agencies and space sector companies to use space technology within developing countries. So I'll talk today on behalf of the UK Space Agency and particularly a programme called the International Partnership Programme. The UK Space Agency leads the civil space programme within the UK, and it's based in 3 locations: London, Swindon and Harwell. It has a budget of about £400 million a year and is part of a department in the UK government called Business, Energy and Industrial Strategy. Part of the role of the UK Space Agency is to form relationships with international governments all across the world and their respective space agencies. And a big part of that effort is the International Partnership Programme. There are 33 projects now in total across 37 developing countries. The International Partnership Programme has a budget of about £30 million per year. This is what's known as Official Development Assistance Funding, or ODA, and it's sourced from a fund within the UK government called Global Challenges Research Fund. The primary objective of the programme is to support benefits within developing countries, such as agriculture, which is the focus of the conversation today. Here you can see a map of all of the projects. 6 of these are agriculture, 6 of the 33. I'll give you an overview of those in a moment. But you can see that the projects spread all over the world, from in the west Mexico to in the east Vanuatu and many places in between. So each of the projects has to have as its primary objective benefits within developing countries, and that benefit needs to be measurable and it needs to be sustainable in the long term after the grants from the UK government end. The projects also need to be cost effective. The space solution needs to be cost effective in comparison to traditional existing ways of solving the same problem. So for example, in agriculture, raising yields. All of the projects have very strong international partnerships at the center of the projects. All of the consortium teams have to have an international partner, for example, an international government ministry, such as the Ministry of Agriculture, or a research institute in the developing country, or a donor and an NGO, or a private sector company like a large-scale agribusiness or an agricultural product exporter. Also, through the programme, there is a upskilling benefit as well to the UK space sector. All of the projects align to the United Nations Sustainable Development Goals. You'll probably recognise Goal 2, the agricultural goal within the SDGs, known as Zero Hunger. And across all of the projects, they align to 10 of these goals, 10 of the 17. And what we do with each of the projects is ensure that the metrics and targets of the projects align directly to the metrics and targets of the UN SDGs. So for example, in SDG 2, raising incomes, raising yields. As development outcomes are the primary objective, we ensure there is very robust monitoring and evaluation of those outcomes. We look to quantify those outcomes wherever we can. And you can see here some examples at the top. In the agricultural portfolio, the focus is on increasing agricultural productivity and incomes for about 30,000 farmers. And then you can see some other examples from forestry, from maritime, from industry, from disaster resilience. As mentioned, the monitoring and evaluation of each of the projects is very critical to the programme. It is hardwired right into the heart of how each project runs, and monitoring and evaluation is set up right from the start of each project. So for example, when companies or organizations propose to the fund a specific project, they have to explain what their monitoring and evaluation plan will be. They have to define what they will measure in terms of success criteria and metrics. They have to explain how they will resource that with a team and how much money that will cost in terms of budget. And then if those bids are successful, we as Caribou Space support those organizations with their monitoring and evaluation, and we provide guidance and review. We provide methodologies and instructions and training as well, so that we can ensure the quality of the monitoring and evaluation in the projects is as high as possible. So here are the 6 agricultural projects. 6 of the 33 projects we have are agriculture focused, and they're across 8 countries. So you can see Latin America, you can see Africa, and you can see Asia. And there are many, many crops within each of these projects. So a really broad spread of the use of space technologies within the agricultural sectors of these countries. This is a figure that is extracted from the report I'll mention in a moment. What it shows in the middle is the types of space solutions that these projects provide. So if you look at the middle left, Earth observation data for credit products for farmers leads to lower down in the outcomes that farmers have access to farming inputs such as fertilizer, because they can source credit and loans, and that ultimately leads to impacts of increasing agricultural yields, improved food security and nutrition. We have a report that's been published and available at this link that really goes through in very comprehensive detail what the opportunity is to use space solutions within agriculture in developing countries. It has many case studies in the back of the report featuring the IPP projects, and also it gives further guidance on where to go next if you wish to start using some of these technologies within your agricultural projects. We have also published reports on forestry and disaster resilience. Another report to call attention to is this registry of products, space sector products. It's available again at this link, and 13 of those space sector products are focused on the agricultural sector. I'll pass to Jacqueline here, but can I just ask, if there are any IPP consortium members from the projects within the webinar, if you could just make yourselves known in the chat box, then I can make a note of that, and I might call to you later during questions and answers. But with that, I'll pass to Jacqueline to continue.
Hello, everyone. Hope you can all hear me well, and thank you for joining the webinar. I'm from Environment Systems Limited, when we are a private sector data and consultancy company. We work both in the agriculture and environment sectors and have an increasing global presence. And we are a partner of GODAN. I lead the EO for Cultivar project, which is one of the IPP agriculture projects, and we have partners in UK, Colombia, and Peru. Our company is also on the consortium of the Drought and Flood Mitigation Service, which provides support to Ugandan farmers. I'm going to talk about the way we make data and products available to our partners in the EO for Cultivar project, and give some examples of ways our international partners will use Earth observation data. We're in month 30 of 48, so past the midway point in the project. So it's a very interesting stage that we're at. So I want to talk a little bit about Earth observation data and what it brings to the table. Agricultural land changes, crops grow, they're harvested. Some are permanent, some are grown in rotation. They suffer from disease and damage from climate events. Earth observation provides a regular time series from which to make consistent observation of these changing land features, making it possible to monitor agriculture and monitor up to scale, so up from field to farm to catchment to landscape. There are many satellites and they collect data via a number of different types of sensors. So we have a range of types of information to use for agriculture to identify crop date types and monitor different environmental conditions, including, say, soil moisture or the vitality of leaf vegetation. The slide refers to analysis-ready data, and I just want to explain to you what is meant by that. Satellite data can be processed to defined industry standards and organized in a form that allows immediate value-adding and analysis by users, for example, as inputs to their models, say a flooding model. Environment Systems provides this kind of data service and the processed, ready-to-use satellite data. And we also provide some simple measures from it, such as wetness indices. These are available to subscribers very quickly after the data is acquired by the satellite, and this data is now acquired very frequently, often on a cycle of 5 to 10 days. The data is published under a Creative Commons open data license. In EO for Cultivar, we add value to this data, providing our partners with simple outputs relevant to their needs in the form of maps, dashboards, and graphs, compatible for use in their GIS systems, their farm and business management platforms, or simply, as some people want, just a PDF map. Satellite data services enable these products to be delivered directly to agricultural stakeholders. Our international partners are innovation adopters. Oh, next slide, please, David. Our international partners are innovation adopters who are demonstrating how decision support tools using Earth observation-based data can support agricultural supply chain management. I only have time to talk about our crop-based products, but EO for Cultivar is also developing decision tools to support sustainable land management through nature-based solutions at landscape scale. The project also provides capacity building. This includes 3 fully funded PhDs being carried out by Colombian students here in UK universities. So we are delivering into 3 of the thematic areas that David has described: increasing production by bringing new forms of information and timely data for agronomy support, improving supply chain efficiency to reduce losses, for example, by having better information about when crops will be ready, and sustainable management of environmental resources and supply chain traceability. Next slide, please, David. This is our theory of change. Well, it summarizes our theory of change. And it recognizes the importance of working with partners at the outset to establish what challenges exist, and then to identify where Earth observation can add value. This includes knowing when to say, this technology can't help you, it's not an appropriate data source. We work with technology enablers, providing them with the data they need, for example, to support irrigation management. We don't deliver data directly to smallholders. Changing working practices is challenging for our partners. This project goes beyond a technical solution. Establishing technical feasibility and even added value is not the end point. Adoption is. It requires organizational scale acceptance and adoption, and this in itself presents challenges. Next slide, please, David. I will now describe some of the products we are developing and delivering directly to growers. Firstly, looking at the field and farm scale. The crops we are working on are bananas, potatoes, asparagus, and grapes. And the slide shows the range of products we are developing for our grower partners. At this scale, we are looking for signs of crop stress, tracking growth, and how well plants are developing against what is expected. In most cases, we are looking to flag issues for follow-up by agronomists on the ground. And in addition, estimating harvest dates can help with logistics planning. Next slide, please. We use the European Space Agency's Sentinel-2 satellite optical data, which has a resolution of 10 meters. And our data services automatically generate an output for the particular crop that the grower has. We are working to ensure these outputs are simple to understand and meet their needs. One limitation of the information, which is the optical data from this satellite, is affected by cloud, but it is acquired frequently on a cycle of every 5 days. So if you're in the tropics, it's quite hard to get data, but in dry, in arid environments, we get very regular optical data. Next slide, please. There are different centres, and we also use a time series of the European Space Agency's Sentinel-1 satellite, again at about 10 meters. This is radar data, and radar sees through cloud and picks up plant structure. So we can look at how the growth characteristics of a plant is changing over time. This is an example for asparagus. The radar picks up the changes in structure with the very rapid growth stage and harvesting very apparent. We can then generate this in near real time for many fields, and growers can compare fields in the same cropping cycle against one another to identify the fields or crops that are performing differently and then investigate why. Next slide, please. In EO for cultivar, we are also mapping crops over large regional areas, in this case in Peru. The map on the right shows you where we are, the area over which we are mapping crops, the area in red. So for regional grower federations and for Farm Advisory Service, having crop maps and monitoring change can help with resource management and strategic planning for smallholder support. The field boundaries in themselves that we create as part of this process are useful too, as they enable a move to digital agriculture. Have the next slide, please. For example, we are mapping table grapes and the locally grown pisco grape as our local partner in southern Peru provides production facilities for small growers for their pisco grapes to make it into a drink. And they want a better idea of whether the area of the pisco grapes is changing. The timescale for the information our partners need here is differently. We're moving away from wanting weekly or very, very regular information for crop monitoring to an annual update or maybe a 6-monthly update. Next slide, please. As I said, to map crops, we create field or parcel boundaries, and we use hundreds of our analysis-ready process satellite images to do this, both the optical ones and the radar ones. And we have fully automated this process. The next slide shows an example of the output. Once the boundaries and crop maps are produced, we will have a baseline and we can start to see where change is happening. Here in southern Peru, where many permanent crops are grown in the desert, the industrial agricultural landscape is actually expanding and has been for a while rapidly. I've illustrated this by putting recent field boundaries over an older Google Earth image. Whilst new crop production brings important income from export revenue, there is an increased demand for water resources, which has implications for the sustainable use of natural resources. Next slide. I want to just point out some of the limitations of the data, of the resolution of the data that we use in this project. The imagery, the Sentinel imagery we use can detect fields to about 3 hectares in size. And you can actually see that on this image. If you look at the top part, the top central part of the image, you can see that whilst there are a lot of regular field patterns all around, it becomes very blocky and indistinct. That's because the scale of the imagery can't pick out the individual management units, the fields, the cropped fields, because the imagery just isn't detailed enough. At present, obtaining images to do that job, they exist, there are plenty of them, but they are expensive to access, so we do not use them. The next slide. This is another example of land use, but I particularly want to use this slide to talk about platforms. As a data services provider, we deliver data for you to use in your own software platform. We don't offer a platform or an app on which to view our analysis-ready data or the value-added data that we are developing. This is because we found that our partners have very differing needs and that there are many platforms available already. Some of our partners have developed their own platforms. As an analogy, we deliver clean water of a known standard, which you can call the analysis-ready data. We provide the water for as many users as our users wish. We are keeping this low cost and competitive to ensure it is accessible to many. We also provide water-based drinks on demand, so that could be our value-added data. This is a more expensive and commercial output. For this, we constrain how those drinks can be commercially shared with others. So you can source water from us and use your own systems, your own pipes, your own buckets, or your own gold taps. We are not selling water or our water-based drinks in a bottle. You can bring your own reusable cup, or we can advise you on what else is available. That's how we keep the data costs low and the uses of the data flexible, so you don't have to buy another system. And that's where I conclude, so thank you for listening.
Thank you very much, Jacqueline and David, for your very interesting presentation and sharing a lot of ideas from all the projects you have been doing. So there are many questions coming in. So we will go to the questions. And for the participants, feel free to ask the questions to the chat window, and we will try to answer them one by one. So the one question from John. John is asking, you mentioned, this to Jacqueline, you mentioned Creative Commons license, and I also heard you don't deliver data to small partners. So how open and available is your data, particularly satellite climate data?
Okay, so climate data we don't provide. So we provide the satellite imagery under the Creative Commons license. And we don't provide that directly to smallholders. That wouldn't sort of work as a model. It's more for those who are wanting to create services or deliver services to smallholders. So it's a data source, but a data source that's ready to use. Once you we base it on a subscription service. So we currently have in the UK, so we're still developing the service. In the UK, we have free data, premium data, and enterprise data, and off-the-shelf prices for those. And we're going to be shortly expanding that model to other parts of the world. I don't know if whether that fully answers your question, but once you have the data, say you wanted to take a free UK satellite image, you can then use that data for other purposes. There's not a constraint on what you can use that data for, and you can reuse it.
Thank you, Jacqueline. There's another question from Godfrey Saga, who is asking, I want to understand the validity in terms of quality of EO data obtained through space for decision making in Africa, especially in Africa.
Maybe, Jacqueline, I'll take that one, then feel free to add on. So the quality of the data, there's multiple sort of aspects to that. The data that comes from, let's say, these European Space Agency satellites, as Jacqueline mentioned, the resolution, or the smallest square you can see is 10 meters, which for many agricultural purposes is quite good, and it refreshes, as Jacqueline mentioned, every 10 days. There's a huge amount of effort that the European Space Agency make to ensure that data is high quality, and there's a lot of effort on something called ground truthing. So this is where either the owners of the satellite and the providers of the analysis, like Environment Systems, will compare what the satellites are saying. So let's take a farm in East Africa growing maize. They will compare the image of that farm, but then compare it to reality on the ground by sending a team there to do direct observations. And through that mechanism known as ground truthing, you can ensure the quality is high, you know what the error range is, and also you can improve the software systems based on how the satellite image compares to what you observe directly on the ground. So those are some of the mechanisms used to ensure that the quality is high enough to make robust decision making. And Jacqueline?
I was just going to say that the data itself is very consistent in terms of the area on the ground being in each image, the pixel, the sort of block of data being collected from precisely the same point each time, which is really, really important if you're using a time series of imagery to create outputs. You want that consistency. And I would say over the years, the availability and the sort of longevity of satellites has really improved. There was a time when there wasn't necessarily an awful lot of satellites gathering data that could be used for agriculture, and you were always worried about when one would just switch off. And that situation has changed vastly. There's an awful lot of good quality data now available. You can rely on it.
Thank you both. So the next question is from Ahmad Mahdavi, who is asking, is the system able to detect pests and diseases?
Yes. So there is a project which I will move to in the slides, so you can, one second. This one, CABI, Pest Risk Information Service, across 3 countries in Africa, that uses Earth observation to predict the outbreaks of pests based on environmental factors. So humidity factors, how much standing water is there, what's the temperature, what agricultural crops are in that region, and then the software forecasts out for a range of different pests what the likelihood of an outbreak will be that would obviously damage the crops, and also makes recommendations then to the farmers in those regions about what to do next to prevent damage from pests. So that is one example from within the UK Space Agency programme of using Earth observation for pest detection.
So I just can add as well from the crop monitoring. So one thing we find is that what the satellite imagery is doing is detecting a crop health, or detecting that there's an issue on the ground. Basically, the plant is stressed. You don't necessarily know why that plant is stressed. You just know that there's an issue in a field or part of a field, and that actually to know the cause of that, you need to send your agronomist, because they're there on the ground. They will kind of analyze why that crop stress is occurring. In many cases, it is because of pests and diseases, but it could be for a range of other causes. For example, maybe the irrigation equipment isn't working, or the ground's too wet. So you can't necessarily always assign the reason for plant stress being pests and diseases, but it's often one of the likely causes.
Thank you, Jacqueline and David. Can I ask this question for Jacqueline? Can I ask, I remember you mentioning about the capacity development in that year for Cultivar project. And you mentioned PhD students working in the aspects of the project in the UK. So can I ask, so are these studentships specifically for developing these algorithms, and so what is this PhDs about?
Okay, so we have 3 PhDs, and all of them are around Earth observation. All of them will feed into our longer term development of our data services, but we didn't want to either constrain or pressurize the students to have to produce something within a project that has tight timescales to produce sort of products and data services and so on. So they're developing a range of things for the future. So they're all Earth observation related. One is on plant modeling, so it's looking at developing or taking existing crop models, say for potatoes or asparagus, that aren't suitable for the environments in which we are working. So there's no asparagus model for Peru or sort of Latin America, and then looking at how that model can be adapted, and using Earth observation as one of the inputs into improving that model. We have another PhD which is specifically looking at within field variation. So we have some measures of within field variation, but this PhD is really taking a detailed look at how much in field variation can be detected, and what might be done with that. And the final PhD is a very specialist one on the interaction between the soil and plant with using radar data.
Right. Okay, interesting. Thank you for that.
I'd also say in each of the 33 projects in IPP, there's a capacity building activity where the consortium, such as Environment Systems, provide training and capacity building to the users in the developing countries. So that could be, for example, within the Ministry of Agriculture, it could be the agricultural extension workers, it could be data analysis teams in the large-scale agribusinesses. So, and that training is to ensure that they understand and can use the Earth observation products, because they are they're not simple in nature to learn from fresh. So so there is training required to adopt those products.
Oh, that's very interesting. So, for example, the way these IPP projects, the local, so there is local capacity development happening in different forms. Is that correct?
That's correct. And yeah. I don't know the exact number for the agricultural projects, but across all of the IPP projects, there's about 1,200, so 1,200 people that have been trained and been provided capacity building in the developing countries from the project teams.
Great. Oh, that's very good to know. Okay, fantastic. There's another question coming from Uludaro, who is asking, how applicable is EO to fisheries, and what type of tools to generate EO data?
Mm-hmm. Yeah, okay. So I'm going to actually try and show you some examples. Hopefully this won't be too disruptive to the conversation, because I also think it would be useful to show this product catalogue. This catalogue, and I'll show you the fisheries examples, is about 60 space products from the UK space sector, and it's categorized in terms of sectors. So if you click on this button, you'd go to the agriculture sector, but let's go to fishing, and there are within here examples of products whereby you can observe marine environments, you can observe fisheries, you can observe and detect potential illegal fishing. And actually, I believe Nick Walker from the company you can see on your screen, Earsphere, is on the phone, on the webinar. So maybe Nick, if you just want to take sort of 30 seconds to a minute just to explain the role of EO in fisheries or oceans. If you can come off mute, let me help you. You're off mute, Nick. Okay, maybe not. But anyways, so use this. You can use this catalogue to identify
I think he's here,
Earth observation for fisheries. Hi, Nick. Over to you for just a minute on the role of EO for fisheries and marine.
Yeah. Sorry, I was struggling to find the mute button there. Yes, one of the things we do is provide satellite ground receiving stations for medium resolution data, which has a range of different collects satellite data from a range of different sensors. For example, which measures the sea surface temperature, which is very useful for understanding what's going on in the oceans surrounding coastlines. So for measuring things like algal blooms, this kind of thing, which is useful for understanding whether the water is good for fisheries. So yeah, we've worked with people in particular around countries like Indonesia and Malaysia, people there who are interested in understanding what's going on in their coastlines. Actually, also we've just been, one of my colleagues has just come back from China, working with people there who are from the Ministry for Fishing, essentially. You can see a little bit of text on your screen there, which explains a little bit more detail if you want to read some more.
Thanks, Nick.
Most of our customers, I'd say, are sort of governmental customers. So they're sort of interested in the how fishing is being affected for their country as a whole, so they can sort of take measures if there are problems, that sort of thing. But I'm aware that there are companies who provide information specifically for individual fishing companies, that sort of thing, trying to understand where tuna fish are, that kind of thing. So yeah, there's a range of different applications for fisheries using satellite Earth observation, certainly.
Thanks, Nick.
Okay.
Yeah. There's other questions coming in. This is from Ahmad, who is asking, are agriculture smallholders able to communicate with these systems with some mobile programs directly?
I'm thinking of the Resitech project there, David.
Yeah, I can cover that. So actually, I can see a lot of the questions, or a couple of them are, and we talked a little bit about this a few minutes ago, is how does the information, or really the advice, the agricultural advice, get to the farmers. And that's really dependent, firstly, on the scale of the farming operations. So let's take a large-scale agribusiness like Environment Systems work within Peru. They might have 10,000 hectares of asparagus, and they might have significant teams and computing systems within their organizations to absorb directly the maps that Environment Systems can provide. At the other end of the spectrum, in terms of smallholders, the mechanism is varied. You can either provide those maps and analytics to, for example, the farming extension workers or the cooperatives, and they will then pass on the recommendations in a form that's appropriate to those farmers, be that through word of mouth, be that through text messaging, be that through other mechanisms, through radio, for example, or alternatively, some of the projects are building applications that sit on the farmers' mobile phones, so both on basic phones with SMS technology, but also Google Android smartphones. And in those situations, you can integrate directly the recommendations that ultimately are coming from the satellite information into the application on the mobile phone that obviously the farmer does have, the smallholder does have direct access to. Jacqueline, anything to add on that one?
No, that was good.
One credit to Jacqueline, because you mentioned for example, the year for cultivar, the local contributors, they can use any GIS system.
Yeah.
Is that correct? Oh, that's fantastic, because in fact, because most of our work is in developing countries. Many of the, we are very we try to make sure a lot of our colleagues use like things like QGIS, the free and open source GIS as well. So especially we find there is a big digital divide in agriculture, and we have been in capacity development working group. We have been trying our best to make sure some of these tools are also accessible to the wider developing countries. So I was very happy to hear that. It doesn't matter. So, for example, if the local colleagues there are using some free and open source systems like QGIS, they'll be able to make use of that, right? Okay,
yes, and as part of the project, actually, because some of our partners are QGIS users, we are there with you on YouTube. We have an EO for Cultivar demonstration, one of our staff talking folks through how to use QGIS for this kind of project.
Oh, fantastic. Great. Okay. And from your experience, what has been, so you have been working with the agriculture extension officers as well, or only the ministry kind of level?
Yeah, like regional ministerial level,
right.
And grower federations, and then grower organizations of different sizes. So we've sort of chosen quite a spread of users to see what's needed and what the variation is, and there is a lot of variation. So we have everything from large growers who are building their own systems as part of sort of broader farm management systems.
Yep.
We have users of ArcGIS. We have ex-users of ArcGIS because they now know about QGIS. We have users who don't want that to deal even with that interface, and they simply say to us, actually, I'm not going to use your analysis ready data. I just want you to email me a PDF file whenever there's a cloud-free image of the status and health of my fields. That's what I need. That's what does it for me. So you've got a big variation in what people need.
Yes. Oh, that's very interesting, and hopefully, I think for this particular project, did you do like training workshops in the country as well, country level?
Yes. So we're on our third iteration of training. I'd actually call it broader than training really. So it's a mix of training and capacity building.
Yep.
So we started out at our user requirements stage with EO Earth observation awareness training for everybody who came along to participate in talking about how this data might be useful to them. So that was everybody from management level to technical to R&D. Anyone who came along just got that basic understanding of what Earth observation is and what it can do. Then we've tended to interact with a much smaller group within organizations, sometimes a couple of individuals, and then they all had a kind of standard. It was QGIS training and some more training on the use of Earth observation. That was sort of the first training, and then the second training became more bespoke. So we've literally gone around from organization to organization, working with them on what they need, and that includes sort of the process of integrating our data into their systems and so on. And then we've held workshops to get people to exchange information about how they found the process. So yes, you need iterative capacity building. Although I do think when you actually develop the products and have all the learning from that, it is probably you know, it's very likely that the process can be simplified a lot.
Yes, and I can also see the sustainability long term as well, because because hopefully, especially the local teams, if they have access to the tools like the QGIS, they will be able to, even after the project funding period ends, the ideas will carry on in some form or other, because then they have, especially in developing countries, one of the biggest issues is if the cost of the fundamental GI tools is very high, very difficult to sustain it. So that's what we were in the capacity when we had a lot of feedbacks, and we have been trying to make sure we now provide all the resources, a lot of free and open tools as well as resources. So it's really good to hear your experiences from that in your project as well. So
yeah, it would be really nice having, for me, the next stage would be, I think, actually being able to have a field boundary, regional field boundary of your or know your agricultural area, know where the parcels are within that. That's that's the beginning of your digital agricultural recording. You've got a recording system ready-made. It'd be really good to get that down to a finer detail, because at the moment we can't get as much of the smallholder growing as we'd like.
Thank you, Jacqueline.
Okay.
We have time for one more question. I will try. So there is one question from Bozia, who is asking, do you have any projects in Central African countries or Francophone countries?
Yeah. So if you can see the slides on the left, so Senegal, it's not an agriculture project, but that we do have a broader international partnership project in Senegal. Let me skip to 1 second. Let me sorry for jumping around the slides. I'm just going to bring this back up. So these are where the African agricultural projects are.
You've got one in Uganda.
Yeah, Uganda.
I think Steph is here if she wanted to talk a bit about that.
Sure. If Steph would like to come off mute, you can mention the project. Okay, maybe not. I can cover it. There's a project in Uganda, GODAN Flood Mitigation Service. Oh, hello, Steph. Feel free to just
clicking on you, but it took a second there.
No problem. There was a question around, do we have any agricultural projects in Central African or Francophone countries? I know Uganda is more sort of East Africa, but maybe you want to provide just 1 minute on your project.
Yes, of course. So DFMS, Drought and Flood Mitigation Service, is all about helping decision makers in Uganda to have better information at their disposal so they can make more informed decisions to mitigate against drought and flood. It uses forecast information from weather models, as well as weather information collected on the ground, combined with hydrology models and products from Earth observation to understand what's happened in the past, what's happening currently, and therefore what's potentially going to happen in the future.
Perfect, thank you.
So thank you, David. I think in the interest of time, we have many questions coming in. So what I will suggest is, the questions we haven't answered, we will write it down and then try to answer through the mail list. So I want to thank all the participants. It's really good to see the interest of the participants and their interesting questions they have sent through. Thank you for your active participation. I want to also thank our speakers, David and Jacqueline, for the interesting and informative presentation. I learned so many things from today's presentation, and I want to thank them both for their time and sharing their experiences with all of us. So thank you, David and Jacqueline as well. So I want to thank all the participants, and we look forward to see you in our next webinar. Bye for now. Thank you.
Thank you too.